So we have now we have Pearl and Abraham here, all the way from Wisconsin.
Yes.
And they're here to talk about progressive web apps.
Let's see. Hi, we are not native developers. We're here representing the mobile web. So we're looking to get in fisticuffs with you native people. We're going to talk.
She said that, not me.
We're going to talk to you today about progressive web apps.
Oh, you broke it. There we go.
Oh yeah. I'm Pearl.
And I'm Abraham.
We work at a consultancy called Bendyworks in Madison, Wisconsin, in the U.S. of A.
Wisconsin is known for people drinking lots of beer and cheese, which we then deep fry before we consume it.
Abraham is a Google developer expert. I have a PhD from University of Wisconsin-Madison that has nothing to do with computer science, in film history. So if you want to talk about 1940s and 50s Hollywood movies after this, I'd love to talk to you.
Over a beer?
Yes, over a beer. Okay. You can follow along if you want with these slides at pwa.today.
Yep, or tomorrow or the day after. And we also have a number of other resources regarding PWAs available on there right now. And we'll be adding more as we find more.
Yes, we have not enough. So what are progressive web apps?
Really, before we actually talk about progressive web apps, we kind of want to take a little step back and talk about what makes a great web app in general. And kind of, in these modern days, the baseline is that it's fast, secure, and responsive. And fast isn't just network speed, but it's also, does it perform well on device? When you scroll, is it smooth? Is there a bunch of ads loading in 10 seconds later that makes your content jump all around? Secure is not just about making sure that the content you are sending to the user gets there intact without any manipulation by intermediaries, but it also is about protecting the privacy and the rights of the users about what they are reading and what they are sending, as well as there's a number of new JavaScript APIs like geolocation and service workers that browser vendors are only allowing to be used on secure origins.
And we also expect a good web app to be responsive. And as we learned this morning, we expect our apps to function and to look good on all our devices.
So now we kind of have the base underlying of like what is a good web app in general. We can now make it more progressive and add in some new features that historically have been restricted to being used with native apps. Like
instant loading, like home screen icons, and push notifications. So why progressive web apps? What is so cool about PWAs?
You could say that they're pawsome.
They are pawsome. So coming from the web perspective, certainly, progressive web apps are much, much cheaper and easier to make than it is to make an iOS app, an Android app, and a website. So instead of having 3 different applications, you can have a single app that can work across all platforms.
And it's built with the standard web technologies you already know. A lot of it's JavaScript. If you want to use TypeScript and compile to JavaScript, you can do that. If you're
CoffeeScript, you can use CoffeeScript, if you must.
Or if you're a Rails developer.
Yeah. And importantly, progressive web apps can improve the user experience of spotty internet connections, especially compared with web apps accessed through mobile devices. So
I think we've all experienced that page can't load error when you're going through a subway tunnel or something. So PWAs can help you get away from that.
No more dinosaurs with PWAs. And PWAs also, in a couple different ways, reach out of the web to engage users in the way that native mobile apps do. So, for instance, with home screen icons and with push notifications, the user can interact with your app without having to go to the URL in the browser. the app can come to you in a way that web apps have not been able to in the past.
And not only is it like progressive web apps have some cool new technologies for your developers to learn and play around with, but they also make a lot of sense just from a business perspective. There's been numerous amounts of studies that fast sites that are are smooth and load quickly keep users engaged longer. Users are more likely to not just walk away, and in turn, they're more likely to leave money with you when they find cool stuff they want to buy.
Happy users spend money on your websites. For example, AliExpress, an e-commerce site in China, had great success with a progressive web app. They saw a 74% increase in the time that users were spending on their app, and that also greatly increased conversion.
So how does all of this newfangled technology work? We actually have a sample app that you can visit right now at sprinkle.works. It is the source code is also available. It's a working progressive web app that has offline support, and one of the things we really wanted to kind of showcase with this was not only is it's not just for your own site, but this sample app also integrates a third-party REST API that called Unsplash, which provides a number of Creative Commons 0 licensed images, and how to cache those third-party API requests and third-party rich media and make it all work offline as well.
This might not work in Safari. We'll talk more about that later.
And it's responsive.
Yes.
Because we covered that responsive is important.
Absolutely. So in creating a progressive web apps, the real hero, the main player is the service worker. Service workers are key to the native-like features that we can bring to web apps.
Do we not have the quote in this slide, in this deck?
What?
The service worker quote.
The code?
No, the quote.
Oh, the quote. No, we were at a progressive web app roadshow put on by Google in Chicago, and a speaker there said that service workers are as awesome as mountains. And we. I
think for here, it should probably be service workers are as awesome as fjords.
Yes. So service workers facilitate caching. They allow your app to, or they're able to intercept requests, network requests, and decide whether to go to the network or serve up resources from the cache.
And you can kind of think of service workers as background JavaScript processes that there's essentially generally one running for your entire site. Whether the user has 1 tab or 10 tabs, there's one service worker that handles, that works as like a background proxy for all the requests and things that are happening. And it does not have any direct interaction with the UI client layer. It's pretty much just hidden in the background, handling events when it needs to be there.
And to create a service worker in your app code, you add something like this. You register you register a service worker, and then once your service worker is installed, you'll get a call back, and you can do stuff at that point. With
4 simple lines, you too can have a service worker.
So this is in your app code, and then your service worker has an event listener that will listen for lifecycle events as well as network requests. Once your service worker is installed, the install event will fire, and you can start to use it.
Yeah, and the install event is one of these stages in the lifecycle where you kind of it runs once for each time a service worker is installed, and then if you deploy a new version of your site that changes the service worker, that will get its own install event once. And so this is where you do a lot of the one-time things that your service worker needs to do. And there's a number of other different states that your service worker can be in. Of course, if the syntax is invalid, then it'll just get an error and the browser will not do anything with it. But then there's like, so if you have an existing service worker and you deploy a new one, when the browser gets it, it will install it and it will complete installation, and then you can kind of decide when you want the new service worker to take control from the previous service worker. And eventually, once that happens, however you handle it, it'll become activated. And you can do some additional activated stuff there. Otherwise, that service worker just kind of like sits in the background in an asleep state, waiting for different fetch or message events is generally what it waits for.
Cache. Caching is a very important and useful thing that service workers can help us with.
We gave this presentation in Chicago a couple months ago, and I don't think anyone there realized that this is actually a euro.
We were trying to make a joke about cache and caching. Thank you for the polite laughter. So one thing that caching can help us with is giving the user something to look at even when we don't have network connectivity. And a best practice is to use the app shell pattern, which I think was mentioned in the keynote this morning. So with the app shell pattern, you'll have your very most basic files cached so that you can render something before you get any data. So in the case of our app, this is what a user would see if they loaded our site for the first time and didn't have any data at all.
And this is basically just like you want to get a very simple but basic and still kind of complete UI rendered while you're waiting for the more extended request to get the data to put in there to render.
Other one.
You broke it.
Our presentation is now broken. Okay. So, so for the creating...
Ooh, we should get some signs we can hold up, and one of them will be like applause, and another one will be technical difficulties, please stand by. That'd be great.
So this code is just showing you a real simple
implementation.
Implementation, that's the word, of the pattern we were just discussing. So we have these basic files that we need just to display the initial.
And also this is so these are actually just URLs that we will then tell the browser to do stuff with, and this actually all lives within the install event callback. So like this, your app gets installed, your service worker gets installed, and then it says, hey, this is the first time that this app has been loaded, so we need to take this list of URLs and cache them offline.
And so this is us doing that in this example, and we are using an add all, which is an all or nothing function. So if any one of the files doesn't load, then it will fail. But
and it's a really good safeguard to make sure that your app gets cached offline completely or not at all. Right? So you don't want to have half of your app cached, so it kind of loads a little bit, but not really. And this is a good kind of stopgap to make sure that that happens. Sumo is a major Japanese real estate site, and they kind of implemented some of these app shell patterns to help cut down on the amount of time it took to render their site, and they had a 75% decrease in load time. And as we've already covered, faster sites means more money. That'd be a good slide.
Yeah, a direct relationship.
Fast equals money. Lots of explosions.
And it's also important that you're not only loading faster, but you're giving the perceived load time is also faster. The user has something to look at even as you're fetching your initial data.
So offline data, we talked a little bit about the app shell design pattern, and that's really more about the layout and the general design of your site. The actual data that gets rendered inside of that can be handled a little differently. And so we can use the service worker to listen for fetch events, and these fetch events are not just triggered by the fetch JavaScript API requests, but also CSS requests, fonts, images, pretty much anything loaded by your page will trigger a fetch event. And then within your service worker, you can check the cache API, which is essentially like a key value store. So you say, here's a request for this font file. Is there a existing cached response to that request? And if there is, then you can just return it from the cache with 1 or 2 milliseconds of delay versus 500 to 1,000 milliseconds if you actually have to do an expensive network request.
And there are different caching strategies, different ways to handle offline data depending on the needs of your app. So if speed is what's most important, then you'll go to the cache first and see if you have a resource, and if you don't, then you can request it from the network. If recency, if having the most up-to-date data is what's important, then you're going to go to the network first and just resort to the cache if there's a problem with the network connection. Or you might want to, use a combination depending on circumstance to get the fastest response that you can get. There are some tools. Oh no, there are some tools. I'll talk about them in a moment.
Yeah, so Conga is a Nigerian e-commerce site, and they implemented a lot of this offline data stuff. So you would go visit, like on their site, you do a search for something, and all the different results on that would stay cached temporarily in the browser. And so, they lose connection because I think the majority of their users had crappy 2G connections that weren't very, very stable. So they could keep browsing stuff that they had already visited, and they actually even implemented a step where you could call them on the phone and tell them the details from, like, the IDs from what you'd already visited and complete a checkout over the phone without having any actual working data connection.
So the shopping channel can still, in a way, it's a little clunky, but can still work, even if the network is coming in and out.
What were you saying before this, Pearl?
Now I'm scared about what the next slide is.
No, you're not. It's okay.
Okay.
Oh, all right.
Okay, so here we are. There are some tools. Google has a couple very useful tools to help manage the caching and manage help you manage offline data. And this is, and we would certainly recommend using these tools to simplify this aspect of things.
Yeah, the APIs we showed you earlier are kind of the low-level built-in APIs that are provided by the standards in the browsers, but they're very clunky, and they're not forgiving if you mess up. And so using these tools, you can do a more of like, here is my app shell stuff, and here's my content, and have it automatically apply some eviction rules based on the caching strategy you want.
So we've talked about service workers, and another newish standard that interacts with the service worker is the Web Push API, and which is a really great contribution to the mobile web, that web apps can now use push notifications, and that is again facilitated by the service worker.
And we kind of know from users can be very defensive against push notifications because of many sites abusing them in the past. So the general rule of thumb is that you only offer enough information that users don't need to visit your site. And this is like, a good example of this is, right, rather than saying, hey, there's a message on our crappy social network, so you should come read it, you just say, so-and-so sent you this message, so that they know what the message is, and they can come to your site to reply if they need to, or if it's just some informational bit that they can already handle, they can just swipe it away and move on with their day.
So yes, the best practice is to not use push notifications, not for clickbait.
Yes.
Because then your user will unsubscribe from push notifications.
Do you think all browsers just automatically ban BuzzFeed from sending push notifications?
I don't know. And this is the push API is a opt-in service. So your user needs to give you permission to give them push notifications. So all the more reason to use the power responsibly.
Yes, and this is handled by the browser. So as an application, you say, hey browser, I'd like to send push notifications to this user. And the browser will prompt the user saying, hey, is this site okay, or are they annoying you? And once that access is granted, your site will get a special token that is unique to that specific device, which you will then want to store in the back end in some database somewhere. And so then from your server, you can hit an HTTP endpoint from the browser vendor. And so Google runs one for Chrome, Mozilla runs one for Firefox, Opera runs one for their browser. And you can send specific data, and it will go to that user. This implements a node library that makes it easier, but it is just, if you want to figure out the key signing stuff, it's a little complex, but you can just do it with a standard HTTP request. And so then it hits the browser vendor. They know which device it is. They'll line the message down. Eventually, it shows up in your service worker, and you can show a notification if you want.
You could do other stuff too at this point, but this is a very simplified example of showing a little notification to your user.
And you could also do some experimental stuff where, like, if you have data that is very time sensitive, you can, or you have data in your app that you always want it to have, always want it to be up to date, and you can push that new data, or you can ping and say, hey, there's new data, and your service worker can then do a new cache request to make sure it's cached as you would expect.
Yes, so this is a useful tool, and not only for showing annoying boxes to your users.
Jumia is another e-commerce site in Africa, and they had issues where people would put stuff in their shopping cart and then just kind of abandon it. And they discovered that people who had push notifications enabled, the mobile web users were twice as likely to come back and convert those abandoned carts than native app users.
And presumably that's at least in part because the users have opted in on the progressive web app to receive those push notifications.
Although presumably the native app users also had to opt in.
Okay, well, anyway.
Presumably.
So the manifest is the last kind of piece of a progressive web app, and much more simple than service workers or the push API. The manifest is just a file that you have in your app that you link to in your HTML. And the manifest allows you to configure what your home screen icon will look like, and allows you to configure some options about how your app is going to display on a mobile device.
And most of these are pretty self-explanatory, like name and description. similar, kind of like a simplified version of information you might put in the Play Store or Google Play, the App Store or the Play Store, and a little bit of branding, and kind of how it ends up looking on a device is you just have the icon with your short name. You tap on that. It'll jump into a splash screen which uses your background color and your icon.
And your full name, the icon, you can specify a short name and a long name in the manifest. And the manifest also allows some different display options. Using display standalone, your app is being displayed in the device's browser. But using display standalone, you can remove the browser Chrome so that it appears like a standalone app, and the bar at the top will have your app name and the color that you have specified in the manifest.
And there's a couple of other different options you can do. You can pick full screen, and then it won't show the top of any of the phone UI if you're building like a web game. You can also specify portrait and landscape, and there's a couple of other configurations you can play around with. Flipkart implemented the app screen icon and saw lots of users coming back and lots of extra conversion from those users.
Yeah, and again, this is a way that web apps now can engage users, can get in front of users without the user having to go to the URL or go to the browser and type in the URL.
Yeah, you get that kind of loved little bit of UI persistently on the device, and so every time the user unlocks their phone and swipes through their app icons, there's your website.
Yay! Okay. So when we've talked about what a progressive web app is, why they're cool, how in quick overview terms how they're made. So our final question is when? When should we?
I think here in the Nordic countries, it'd probably be after having some coffee.
So after your coffee, and once you've warmed up, when should we start building progressive web apps? Browser support is not
universal.
Not complete. Yeah, if your users are all using iOS devices, this might not be the time for you to build progressive web apps.
But there are also, like progressive web apps are a collection of the various different APIs, and so like the app shell thing is a great pattern to use to make your app more performant regardless of what browser you're in. It doesn't need offline caching, it doesn't need it doesn't need to be used only in Chrome. It will make your app that's loaded in Safari faster as well. Edge is making a lot of progress in adding a number of these different features. A month ago, 2 months ago, they added the Fetch API, and they've committed to, I think in development is the Service Worker API. Safari
has made positive signs that in their next 5-year plan, they would be interested in thinking about these technologies.
So once Service Workers version 7 gets finalized, Safari will be implementing 1, I guess. I don't know. So really, it's about 60% of global browser usage will can support all of these cool new progressive features.
What about the other 40%? Well, these are progressive web apps, and the idea is that your app should still work, should still be a good app, even if not all these technologies are supported. There are polyfills for a number of parts of progressive web apps, not service workers. You can't polyfill a service worker.
No, but you can kind of you can also. Even if you don't want to use a polyfill, you can use a transpiler, so you can write in TypeScript, or you can write in ES 2015, ES6, and have it just kind of get converted to an older JavaScript. And you can basically make it work. There are some workarounds that you can do with some of Safari stuff. So Desktop Safari has push notifications, and the application cache, if you're a masochist, you can implement that. It has very weird edge cases, like, so you basically like give it a manifest file that lists all of your files to cache, and then it will render all of those files, I think even if you're online, if one of the files is not cached offline, it will not render that, even though you're online, so I would say avoid it.
Yeah. But it's deprecated,
it is an option.
But it still exists. So in any case, you will always, when using these new technologies, want to check for support. So just, you can see, does a service worker exist, and if it does, do all your cool stuff, and if not, your application can still work just fine.
Yeah, this is essentially like, this is the core linchpin fork where, is it a modern browser where you can add in all these special progressive features that will make your app that much faster, that much more secure, that much better for the user to interact with, or can you just display the standard good application that you already have?
So when? Now. There are lots of really wonderful progressive web apps in the wild, and at PWA Rocks has a nice collection of them to look at.
And this is run by Opera Developer Relations Team, so if you have cool PWAs, you can do a PR and get them added.
Or if you fix their service worker, you can do a PR and get that added. We have for you in our slides a bunch of resources. I know that you probably can't read those.
If you can't read those in the back, we can read them for you. https://
No, we're not going to do that. But the slides are available at, you can find these slides for this talk at PWA.
And once you find those slides, you can find this specific slide and then get all the other resources.
Yes, yes you can. So, so that's it. Thank you very much. We're from BendyWorks. We would love to build.
We would love to come back to Norway more. So you should hire us and then have extended getting started sequences
and we'd love to keep in touch. So please feel free to get in touch with us anytime. Thank you.
And